Hello, I am Alex Zharichenko. There's also should be another person here, but I'll get to that in a second. So I will be talking about Pitt API. This is an API that's developed by the Pitt Computer Science Club, mostly just to help expose just data about Pitt in general, about a lot of different things. You can find it just at our GitHub. So this talk where I'm going to just go through is this is sort of Ritwick's story about developing various ones and how we actually get to those points, and then a little bit of just like showing off just what we can do. So yeah, unfortunately Ritwick's not here because he just occasionally, yeah, he's in some faraway land, I don't know where. But one of the things about Pitt API is that it's just sort of just this thing about liking having more open data, and that's what we're sort of just trying to strive for. We're not like the only university to have some sort of API that exposes different things like course and textbook. CMU has one. There's a bunch of Canadian universities that have them. There's like a whole website that's just dedicated called like campusdata.org that just a bunch of people like trying to expose this stuff because there's a lot of good uses for it, and sort of just like getting involved with that is just awesome. But PittAPI is basically just a really good collection. It's a really good Python library, good collection of just different things. So we have courses, dining, labs, laundry, all of these just different ways to access just different things really quickly and easily. So what we're going to look at today is just how Ritwik went through lab, laundry, and shuttle. So you're going to have to pretend that I am Ritwik. So the lab API. This one, a little preface is that at all our computer labs on campus, that's a that's great. There was a bunch of screens everywhere that shows like different information about like the time, weather, when the lab closes. But one of the most interesting pieces that it shows is how many computers are available in the labs. So it says like there's like 40 Windows computers or like 10 Macs and 2 Linux machines that no one uses. And then even more cool is that they have this availability. You can check it online directly. You don't have to like just go into any computer lab and check yourself. So what Rick was wondering, where is the data source and how can we access this? So he got out the very, very trusty tool in any web browser, the developer tools, hitting F12. And so this is where he's just started to investigate, how is this page being fed? The answer to that is kind of just a little bit off. So after looking around in the developer tools, he found a link that pointed to that what could basically just be plain text of just literally just saying alumni lab is currently closed, Venom is open with 43 windows, yada yada yada, with the weird URL that has recently just been changed to just, you can literally look this up yourself. It's lab information, that's cssd.pitt.edu. Yeah, it's very interesting how they literally leave that exposed, but what we did is we sort of grabbed our tools of the trade. It's really basic. We use request library to fetch the information. We use Beautiful Soup to help digest all the HTML, which in this example wasn't really much at all. And then we use Gevent sometimes, not like directly. The only reason why we're using this sort of coroutine asynchronous library is because there's a certain version of requests called gRequests that lets you do a lot of like requests simultaneously at the same time asynchronously, so you can actually do things a lot faster. But in the end, after combining a couple of these libraries together and doing some quick things, we have that. That is how easy it is and to get information about a library. Though this seems, it looks really easy. Anyone can really just like do this. They can just go on, make a simple scraper. But not every single API that we've done is actually this easy. Probably one of the worst ones that Ritwik has dealt with and that I've sort of almost dealt with was we have an interesting thing called Laundry API. So there's a third-party company that Pitt works with to provide laundry to the students that hooks into all our systems and whatnot. And one of the things they provide is tracking for the laundry machine, so you can see which ones are available or which one, or if your machine is done or not. And so when Rubik saw this, he's like, oh, jackpot. Opens up developer tools. Let's see what we can get. Oh, cool. There's dynamic data that we can just grab directly. Let's go right in. And then he ended up at this. I think that is the only way this slide can be described. There are many better ways to compress data. This just isn't the one. So for some reason, laundry people were encoding data, which was one problem that had to be figured out is what does any of that mean? The other problem was every time you wanted to get this data, you needed a session ID, which you get from just going to the web page. The issue is if you use anything like requests library, that doesn't actually happen at all really easily, and you basically fetch nothing. Like if you try curling it, you won't get anything out of it. So it took him a bit of time to figure it out. He finally figured out how to, you can use a session and you can easily grab what the sort of session ID that you get from it, and then you can call it directly. That's how he did it. But then he still had to figure out what the numbers mean. There's actually, like, I think there's actually a quote that I got from his blog where he's just literally saying, what was it? At this point, I thought of getting a degree in cryptography or something, as he was looking at these numbers. After observing it for probably like a day or two, as his blog described, he figured out what the first number meant was free or occupied. The second was time, and then this one out of the blue, it just either means it's available or empty or out of service, and then the rest numbers we don't know what any of them mean at all. It's kind of also sad that he put a lot of work into this one, though if you look at our current way we do it, some grad student figured out actually that there's like a mobile version that you can easily, then we just take out, it literally just says like machine, time, everything very verbosely, and you can just easily use Beautiful Soup and just parse through all that. But that was like probably the hardest one. But then some of them just amaze me how actually easy they are to actually get at. So this next one is the shuttle. So Pitt actually has this, which is kind of cool, though it's by Rubik standards, it's kind of also terrible. So this basically shows like there's a lot of Pitt shuttles that take kids that are either further off campus or at other off-campus housing that are on campus housing that happens to be a little bit farther off campus. So it shows you all the shuttles like the Port Authority would here. So how easy could this get to figure it out? Well, the way they designed the API was just they basically just hard-coded the API keys right into the code. It didn't take us long to literally just find it, and then all the responses were JSON. So this was literally just simple as requested, and then here's the JSON. Have fun. It is one of probably the easiest ones to use, though the data is a little bit obscure. And this is also sort of him saying, yeah, if anyone wants to take the initiative on actually making a better one, which I don't know how, because I think the one they currently have, but that's pretty much, it's pretty much few of them. They're not like the hardest things to make, but trying to actually get them and update them is kind of annoying. So let me just actually show a little demonstration of actually using it live. So one of the so besides any of that, one of the cool things about Pitt APIs is actually really easy to use, and that's part of why I'm also doing the talk. So Rubik and a bunch of other people are the people that made the APIs, but I'm the one that maintains and actually makes it good. So show you live. There we go. Oh, okay. So let's open up Python interpreter. Okay. So really easy. If you want actually to get the Pitt API, it is available on PittAPI. So you can just do pip install PittAPI. It's actually as simple as just saying. We typically try to keep it up to date, and if there's any like bugs, always just like if you just message me, I'm pretty much the only one that's maintained at this moment. But to import stuff from PittAPI, we have like the list of modules on our repository, and we have a sort of good documentation. It does at least explain like how each of them works, and you'll give you a general response of what the response from it would be. But yep, I'm not up there. Oh, that explains a lot. What? There we go. Okay. There we go. Okay. So I'm going to start off with just like one of the APIs that I mostly did a lot of refactoring on. It's called Course. It's a really easy one to use. So all it really has is two things. It has get class and get classes. What that means is, so for example, I can say get classes, and then you need to, if you're a Pitt student, this is more familiar to you than anyone else, but it's really easy to get this. For courses, we fetch directly from a website called course.as.pitt.edu. It's one of the school's websites that show the list of every single class that's happening during a single semester. So each semester has their own sort of term code. So this is the one for the fall. And then the subject code is the next thing they have to enter. So that could be, for example, computer science would be CS, or psychology would be PSY. So for this one, I enter that in, and then boom, there's this wonderful just plethora of JSON. Let's make that actually a little bit easier to look at. Course. Come on. Yeah, it looks like there's a lot of courses, but it does show the basic things like the class number, how many credits, whether there's an instructor on it or not. So if I go up, there's, let's see, there's like the Introduction to Programming course. So I can see it's 3 credits, Python. One of the most interesting, cool things you can do is you can actually, if you take that class number, there we go. I can also then say, I want to look at this one class. Okay. So, whichever this one is. Come on, I need actually a real course. Graduate. There we go. 1, 4. Yeah, live coding isn't just fun. There we go. And then I can now get more information about that certain class. Like it tells me what the description of the class, where it's being held, what days of the week it occurs on, and what time. So now it's not only that we can actually be able to fetch like every single course at Pitt, I can also actually do a lot more things. Like I can tell you, I can help build schedules. I can figure out in every single room on campus what's happening in that room at any point of the day, because you're actually given just enough. You're told a vague code of what the building is and what classroom, so you can, if you have like all of the information, you can then just start putting all these things together.
So like when you do that list of classes or this individual get class, is this going out and then, I know it's hitting some server, is that server then going out and like hitting the web page and scraping it? Like,
so what's happening
in response to your request, or is there like a cache or a database in the middle or anything?
Yeah, so the easy explanation, this is the website that it actually fetches from directly. Every time you click on this button, there's a certain query that's made, and this is what I'm fetching from. So for like get classes, I fetch and get this, and then if I click on an individual course, this is what I'm getting, this is what I'm getting from the class specifically, that information. This comes from, it is sort of, I don't understand entirely how it's being done, but I know that the school has something set up with the data warehouse with IT, and they occasionally, just every once in a while, just update this, so it fetches from some database, and that's where and the web page just fetches from that. I don't understand.
But I mean, your guys' code with the API.
Yeah, for us, we literally
every time you hit the API, it hits this web page.
That's all.
There's no caching. There's no buffering.
Yeah, there's none of that. It's just we literally grab it and go. Though that did actually introduce a weird problem. I wonder if I can actually see if I can get it to actually happen. It eventually does it. Fun fact, they actually eventually put up, if you go enough on any of these this course website, it will come to actually do a check if you're human. Yeah, that's pretty much actually, that's probably at the Pitt API's fault that they had to for some reason do that. I am actually amazed that we have put so many requests out that they had to actually do a check. Though I haven't seen it a lot recently.
It'd be pretty easy to hammer that site with like a for loop, right?
Yeah, pretty much. I have done it a few times. Though there is a better sort of API that I'm built. There's a better web API version of this that I am slowly trying to build up. But I'll show you. There's like a public-facing one that does actually hammer the website very heavily like that. Other ones like I can look at. Let's see. Another API is Lab. So I can use Lab. It's very easy. It only has one function of get status. And then the only other thing you need to know is that there's just a constant variable called locations. So if I want to know what the location codes are, then I can now say get status on, I want to see how many computers are available in the Hillman right now. 78 Windows machines, 24 Macs, and 2 Linux. That's actually kind of incredible how I think on my slides there was actually less Windows machines open. So I guess some people are still on campus right now. But otherwise, the rest of this you can view right on our GitHub directly, and the API is very simple and easy to use. A lot of it's not very complicated information, but yeah. Let's see. But otherwise, the main thing is what we have is it is brittle, and it's kind of being harder and harder to maintain because I am so far the only person that actually maintains it. It does break every once in a while. Like we had like a Unicode issue with it for some reason. There was a change in one of the APIs, how Pitt did it, and so it's like this is really just very hacky at best. But even at that, in like the last 2 years, Pitt has been there's been a mobile app challenge that Pitt has been hosting like every year. And like the last 2 years, the winners were actually using PittAPI to fetch information about like labs or classes or any of these things. So this is actually like something that people, or specifically students, are actually using to innovate. And so what sort of I am trying to do, because I am also the business manager for the Pitt Computer Science Club and also leader of the projects, I'm trying to actually try to do they've been trying to do this in the past, but I'm going to try my best to do a full push to actually make Pitt actually make this instead of us, because they have a better access to everything. So that's sort of our goal, is to actually get Pitt to open up, make an API so that the students, could help innovate and make our lives better somehow. How, I don't know. But it's just like, sort of even like further in general, just open data like this is really nice to have. If there's legal data out there, it should be open, so go make it so. Because even if a lot of the data isn't useful, it's useful to somebody. or it could allow or somebody could have an idea to actually innovate on it. So I could, for example, make a better scheduling system than the one Pitt has, and that can account for, hey, I want to actually be scheduled with my friends, so how can I work out that and work out with my friends? So sort of you can take these sort of problems and be able to, because we are allowing such easy access to all these things, you can easily go ahead and attack these problems much more effectively and easily with code. And that's why open data and and this is why the project exists. This is why Rivik sort of made it, because he wanted at least the University of Pittsburgh to be more robust like this.
What kind of things have people built? Are there any like sites that like other people like? Is there anything you can show us that's built around this?
Unfortunately, I don't particularly know.
Okay.
You can look at last semester's winners.
Yeah, I can try that, because because most of any other usage, Rivik knows much more about, because he interacts with more people than I do on this. But let me see if I can find. I know. So one of the Pitt mobile app challenges was sort of like a Facebook on like Pitt's It was like a chat bot. So basically, you can chat with it, and it can give you information. So one of the things was they were using PittAPI to actually help fetch some of the information. I forgot, what was this year's? Yeah, it's taking a bit to load. Or like at least one of them. I actually don't know. Yeah, I don't actually know in particular which one actually did it. I know some winner was using it. It probably is this dorm one, for all I know, probably using like the laundry one to actually tell you information about like the residence hall and laundry and all these things, maybe, but it's still social. Yeah, unfortunately, I'm not the one that actually really knows. I'm more the one that just helps trying to maintain and like deal with bugs or anything when it breaks and sort of stuff. Ruvik's more the one that sort of helped like try to push this a little bit and try to get Pitt to do it, or try to like see what people are doing with it. So
you want to show us some code, like some scrapers or
some scrapers?
Something behind it.
Okay. Like I'll show you. It's not. Some of them are relatively easy. Like if I open up Lab, so Lab is so darn simple. So all you do is step one, you throw in the lab name. It will then I had to do a lot of validation. The validation basically just says, hey, does this actually belong in the list, and uppercase it, and then the other thing is we basically every time you call it will fetch that whole entire lab's plain text. So this is what it currently is right now. So basically it just fetches this web page directly, and then when we fetch it, lab. It looks like I think there's some issue with it not fetching correct on the first time. So it looks like it basically will just continuously try to request the web page until it actually comes up. I don't think it's an issue anymore, but I think that was an issue in the past that it had. And then so it's really simple. We use a request session to get it. We use Beautiful Soup to quickly get at what we need, which in this web page, it's really, really simple. Oh, that's not fun. There we go. You don't have to go really far into the web page to get to what this element is. So it didn't take us long to quickly just say like, oh, soup, go to the span, and then go to the text of it. And then all we do is strip to make sure there's no white space on either side of it, and then split it up by spaces. Because even though it's not obvious in here, there is, for some reason, there's two spaces in between like the period and Benedum. There's two spaces. It doesn't, I think it has to do something with encoding that it appears, but that's really great for us because that helps actually split up. The rest of it's really easily. We just figure out where it belongs. We split up the text, And then the rest of it is just we figure out if it's open or closed, and then if it's open, we go ahead and try to pull out, okay, here's how many Windows computers, here's how many Linux computers, and then we just return you a Python dictionary. Some of the more complicated ones, like laundry, which I'm going to attempt this one, even though it's really, really weird. Laundry is a very strange one, so you have to take, like, you have to get the building code, and then it's going to, I think we actually made this one a lot easier. Yeah, I'm not going to attempt that one, because, but the courses one is probably a good one. Getting classes. Let's see, what is... Get subject, extract course data. Yeah, sort of some of this you have to look at it, but for get courses, if I remember, it's this little same thing where we use requests to get the web page. We put the web page text into beautiful soup so we can easily go inside the HTML elements. And so with the web page, oh, come on, there we go. We know that, for example, this whole thing this is all contained within a certain, I think it's like T-body, and then these are all just regular rows with columns. And so this is basically how we know how to parse this. So all we do is we just go row by row, and we're just pulling the information out one row by row, because we just know that it's going to be formatted like this, guaranteed, because all the other queries are formed like this. And then we just throw that into dictionaries and throw that into huge lists, and then give it back to you.
Okay. And then the whole thing is what, served up with a Flask server or something like that?
Yeah, there is. Yeah, so there is. This is our standalone library. We have a Flask library, so this is where another project that I'm going to change up a lot, because this is really bad. I will specifically show how bad it is. It is literally, we have a Flask server that's actually currently running, and I'll show you the URL in a second, that all it does, it just basically calls the Python directly, and then we'll just spit out the dictionary into JSON. So, for example, if I want to get all the classes happening semester for computer science, the website is api.pittcsc.org, and then you just do /. So all the details about what the endpoints are all just in the README. So if I want the classes, it looks like I just need the courses, the term, and the code. And so in this one I have courses 2191 for the term, and then CS, and then if it fetches, there we go. It's a great JSON response. Definitely a future goal is I'm trying to make this, but now implement things like caching, because a lot of this stuff you can just download once, and then you can just fetch forever, because usually for a certain time the data like class changes a little bit, but then once the semester is happening, or once like a semester before, it's usually all solid. Some of them are a little bit more difficult, like if I'm trying to fetch lab or laundry. Those are a lot more dynamic, and they have to be fetched either more regularly or just, in this case, just go directly.
You have, given the volatility of the structure of the data, do you have test coverage that will help you automatically detect if things are breaking?
Yeah. We do have, so on our main library, we do have tests that are in place. Most times that if anything breaks with like a scraping tool, it's usually that someone changed how the API is on the outside. But though we do have the test also there to help maintain like consistency of this is like the response you're going to get, and we try to actually test for that. But pretty much most of the time when the API breaks, it's because Pitt has changed something somewhere.
Right.
So which is kind of,
it's kind of a way that you can proactively detect that.
There definitely is a way. We just don't bother to implement, because a lot of the stuff typically stays pretty consistent. it's sort of just we're waiting till something breaks, because that's sort of how we're waiting till someone finds something to breaks. That's really how we're doing right now. A better way would definitely like try keeping the tests to automate more, so that they actually just happen regularly once in a while to see if there's an error that will occur because of the API, or just some way to check like the status of the APIs continuously. But we don't do that because we don't. Not a lot of people are contributing to this, and I'm not sure how many people are using it. And I think also a lot of our goals is more towards, can we get Pitt to actually make this a reality more than us, so that all those issues are more onto them and they will be able to take care of those things much better than we could ever.
Shaying would help hedge against that too. It would also provide that effect. If you already have a local cache of, say, all of the, not for the dynamic stuff, but some of the older course information, and something external, one of their factors on their, I think they run Oracle. Something on their
they run
changes,
Oracle.
Then you already have that information, and you have time to respond to that while you still have some older, possibly information. But
like it's not hard to keep up, and the things like courses don't break. Like, I haven't seen it broke. It's all the other things that break. Like, I think the most recent one that broke was our people API, because some little thing changed. So like if I search like people, I can search for me. Like, it's stuff like this that breaks a lot more often, and I cannot account for. Like, I cannot account for like people, the people API. That's mostly just because that people come in and out of the university, and you're giving it a certain query. So some of this is just really just challenging to like. It's not hard to keep up with, because we can easily. A lot of this is just like fixing what are we specifically scraping for, or what is the URLs we're trying to actually go after. But sort of what it is. It is what it is.
Yeah, it was interesting when you were dumping out all the courses and whatnot. I jumped an old professor in like the 90s. I guess he got tenure from Daniel Murphy.
Daniel, probably could. Yeah, it's anyone at Pitt, so it's like any faculty or students will all show up on here. So yeah, we have department is computer science and phone number and everything. Wow. Yeah, you can query anybody from here. I'm trying to think, is there anything else? That's sort of it. This is sort of just like what the current state of it is. Right now, a lot of any development on it is currently pretty much stalled. It's more the next semester is when we're probably going to kick into more trying to actually add more things, because we still have a lot more room to grow. There's still a lot more APIs that actually can exist, and that's very clear to me when we look at this is a website that exists. This is what I was talking about. There's actually a lot of other APIs, and sort of one of the things is, can we actually somehow achieve all full check marks about everything? There's a lot of things like athletics, buildings, printers, and all those other kinds of things that we can try to like go after. And that's sort of what I'm going to aim for next semester, is trying to encourage people to help actually contribute and build these new ones, and then also further trying to actually convince Pitt. And then the other thing is, I'm also really this is sort of what I'm trying to do for my club, is trying to encourage projects that build off of this, or find unique ways to actually use these tools of open data and see what we can do with it. Any questions? So yeah, this basically, they rank it by how many of them you get. So this is basically showing all these different universities. Some of these APIs that other universities have are either university run or student run. I know, for example, University of Maryland, actually their API is, I think, run by the university. So it's much more. It's much better than some of the other ones. And some of them are just really ridiculously. I am amazed at how well they did scraping all these things. What's the one? There we go. So yeah, like some other universities actually make like really some of this like students or the university. I think actually this one is actually some student actually, and a few students build this. Was one for what was it? University of Toronto. They built like an entirely like robust one that actually works, that has things like caching built in. Literally, I think they basically have a cron job just going, and that basically shoves all the data they get into a GitHub repository, which then they fetch from to then provide data. Some of these universities have some of the universities have, or students have like very interesting ways of doing it. Yeah.
So has the Computer Science Club made any contact or like try to reach a line out to its tech sector to be like, hey, can we get some support
from
for official API yet?
Yeah, so from what I know, there was talks, but unfortunately I don't really know. I don't think they went anywhere far. So I'm sort of now making my attempt towards that. I think they actually made some progress, but I think the person might have gotten, too busy during the year to actually help just like try to tackle this, because there's a lot to tackle with this, because you have to convince a lot of people within the university to actually support and show that there's a want for this sort of thing to actually allow this to be public.
So maybe it's just faster to just scrape first and
Yeah,
people to do something nice.
Yeah, this is sort of like, even though we can do very terrible things, like constantly throw requests at their websites, this is one of the case of just do it first and then ask permission, or no, what is it?
Ask forgiveness later.
Ask for forgiveness later. I don't know why I forgot the quote entirely. Yeah, just do we're just gonna scrape everything, and then we'll ask for actual permission to do things much better later.
Well, with the establishment of the new school, I think.
I definitely think with the new established School of Computer Science, School of Computing and Information, they probably this year they might be a little bit more open. At least the school would be open, but the school would probably be a help in trying to convince, because I know there's a lot of people to convince to actually make this happen. And I think the most hard target that we have to get at is the Pitt IT. Because they're the ones managing the whole data warehouse that actually will contain like all the things that you can query from people, all the things you can query from courses, lab information. All of that is all controlled by them. And it's sort of like, how can we be able to have access to that? Because to get access to such a thing, you actually have to have like you need like faculty and other people to actually help to actually get that. Though there's some examples of Pitt exposing that, like the school, like the Teacher School of Arts and Sciences has the course website, and they are fetching from the data warehouse, though it looks like how they do it is they sort of just update it. It's not like this doesn't fetch directly from it, but it sort of updates from it from time to time. Because, for example, there's no instructors here, though if I go into our system for Go scheduling courses, every single one of them has instructors and all the other information that it needs. So it doesn't look like this sort of fetches like once in a blue moon, and then it's done. But yeah, that's Pitt API.
Great, thank you so much.
Very insightful.
So if anybody still has any more questions, wants to hang around and chat, we'll be up here for a couple minutes, and then we usually head downstairs, Sharper Edge for beer, if you would like to join us. And then otherwise, yeah, we will see you all next month. Thanks so much.
Thank you, guys.
Yeah.